Welcome to Geo. Bachara, today I am going to discuss about screw gauge. So first we shall discuss about the different parts of a screw gauge. So here you can see this portion will be called as ratchet. And here one hollow cylinder is there, and on the hollow cylinder some marking is given, counting is given, or scale is given. That scale will be called that circular scale. And if you move this circular scale, this type of one main scale will be available, so that this scale will be called actually main scale. And this is simple nut, and this is a cylinder, spindle, we can tell it is a spindle, and this one is stud, and this is U-shaped handle or U frame. So these are the different parts of a screw gauge. Now if I want to measure the diameter of any cylinder, you have to place it like this. You have to place it like this, and you have to tight, but final tight you have to give by moving the ratchet, and this type of two sounds will come. So means it already fitted. So now you have to find out the main scale reading and also the circular scale reading. Now I am going to discuss about the error, zero error. Zero error means first you have to close it. Now it is totally closed. Now you have to find out, is there any error is there or not. So here the main scale reading, you can see this is the zero of the circular scale. So this is the zero of the circular scale, and this is the baseline. I forget to told about the baseline. So this is the baseline of the main scale. So when the baseline of the main scale and the zero line of the circular scale will match, that time we can say that it does not have any error, means instrument is fit. But sometime it happens that the zero scale is crossing this baseline, or sometime it is not reaching to the baseline. So in that case, when the zero line will cross it, that time it will be called negative error, and when it will just remain before the baseline, then it will be called as positive error. So these are the concept about the zero error. So this is the matter. Now let's find out, or let's calculate any diameter of any object. Now before going to measure the diameter of any cylinder, we have to find out the pitch and least count of this screw gauge. So pitch formula is there. Formula is distance moved in the pitch scale by number of rotations given in the circular scale. So what does it mean? Pitch equal to distance moved in the pitch scale. So distance moved in the pitch scale means suppose here you want to move it, just okay, from beginning I am doing. Suppose this is 0, here 0 and 0, this base scale is matching. So now we are going to move it. One rotation we are trying to move. See here 0, again 0 came, means this 0 came again, it is matching with the base scale. So in this condition means it is moving one scale, it is moving 1 millimeter, actually it is moving. So here 1 millimeter moving, and number of rotation given means that is also 1, means when we are first it was at the 0 position, then again when it come back after rotation at the same position, then one rotation it has done. So one rotation done means actually distance cover. First, if I want to write it, pitch equal to first one rotation means 1 millimeter, and how much rotation? One rotation, no, pitch equal to actually distance move in the pitch scale. So distance it move 1 millimeter, and number of rotation how much we done? 1. So means 1 by 1 equal to actually 1 millimeter. So 1 millimeter. So here 1 millimeter we can write it as 0.1 centimeter also. So in this scale the pitch is actually 0.1 centimeter. Now let's find out the least count. How to find out the least count? There is also one formula, that is pitch by total number of division on a circular scale. Already we got that pitch equal to 0.1 centimeter. So here 0.1 centimeter by total number of divisions on the circular scale. Here you can see 0, this is 0, and this is 90, and this is up to 0 means this is 10 divisions are there. So total 100 divisions are there. So means 0.1 divided by 100. So 0.1 divided by 100 means 0.001 centimeter. So this is the least count, LC. So LC equal to 0.001 centimeter. So pitch and LC we got it. Now let's do the practical. Here I want to place this cylinder, and then just move the ratchet. Okay, this setup has done. Now let's see, this scale has moved as 1 2 3 4 5 already written here, and 1 and 2 means 6 7. So 7 complete line it covers, means 7 complete line means division means here actually 7, let me write it, 7 divisions. 1 division is 0.1 centimeter. So 7 into 0.1 centimeter, but it is not done completely. Why? Because here you can see it after 5 divisions, some little more it crossed the division. So in that case we have to find out the value of that portion also. Now to find out that portion we have to see that which line, just you can see here, 1 minute. Here if we see carefully, you can see here that this is 20, this is 25, but before this is 24 means 24, with the 24 division this base scale is matching. So 24 means we have to calculate how, already 7 divisions covered, and then we have to do the plus 24 into least count. Least count means 0.001. that is centimeter. So if I calculate it, then the total value will come. Let's calculate. So 7 into 0.1 means it will come 7, 0.7 centimeter plus 24 into 24 into 0.001, then it will come 0.024. So 0.024 centimeter. So now if we add it, so plus 0.7, then it will come 0.724 centimeter. And so this is the diameter of this cylinder, and as there in this screw gauge no error is there, so we no need to do any subtraction or addition. Mind it, if the positive error comes, then obviously you have to subtract that value, and if negative error comes, then you have to add that error. Okay, so in the case of negative error you have to add, in the case of positive error you have to subtract. So this is the rule. Later we shall discuss elaborately about it. Today up to this much. Thank you.